we're going to do some more implicit differentiation problems here. So let's just get to it. All right, I have x to the 9th, y to the 6th minus y equals x. So what we're going to do is we're going to take the derivative of both sides. So by doing that, so we know that the derivative of x with respect to itself is 1. So we're going to split this derivative up like that. Now what we're going to do is this is a product. So we have to do the product rule. So we take the derivative of the first one, leave the second alone, plus the first one times the derivative of the second minus dy dx equals 1. So we know the derivative with respect to x of x to the 9th. That's going to be 9x to the 8th, y to the 6th. And we know the derivative here, or sorry, we know x to the 9th here. Now if this was x to the 6th, the derivative would be 6x to the 5th, but it's y, so it's 6 out front, y to the 5th, but then we have that additional dy dx. So then what we do is we get all the terms with dy dx on one side and all the terms without it on the other side. So we have 6x to the 9th, y to the 5th, dy dx minus dy dx equals 1 minus 9x to the 8th, y to the 6th. At which point we factor out dy dx. And then we divide this term on both sides. So we have dy dx equals 1 minus 9x to the 8th, y to the 6th, over 6x to the 9th, y to the 5th, minus 1. So that's how we would solve that particular problem. That was a little too cramped. I apologize for that. The second one, cotangent of y equals 3x minus 2y. So again, we take the derivative of both sides. Now the derivative of cotangent. Now if it was cotangent of x, the derivative would be negative cosecant x, but it's not x, it's y. So it's negative cosecant squared. Negative cosecant squared y dy dx. Now over here, we're going to split the derivative up. Now we have negative cosecant squared y dy dx. Now the derivative of 3x is just 3, that's not a problem. Now the derivative of negative 2y, again if it was negative 2x, it would just be negative 2. But it's not, it's negative 2y, so we have that additional dy dx. So let's get all the terms with dy dx on one side. So now I have 2 dy dx minus cosecant squared y dy dx equals 3, at which point then I can factor out a dy dx, so dy dx 2 minus cosecant squared y equals 3. So that leaves me with dy dx equals 3 over 2 minus cosecant squared y. Alright, so that's how we would do that. Finally, we have this thing. So there's a couple ways to do this, and we're going to do it the hard way first, because why not? So if I was going to do this the hard way, by taking the derivative of both sides, I would have to follow the chain rule, because I would have to do 6 times cosine pi of x plus sine of pi y to the 5th times the derivative of the inside, which is negative sine pi x, and then the derivative of its argument, plus cosine of pi y times the derivative of its argument, and then the derivative on the right hand is 0. So now we've done this, we have 6 cosine pi x plus sine pi y to the 5th times, well, that derivative of pi x is just pi, so that's negative pi sine pi x, and then the derivative of pi y, again, if it was pi x, it would just be pi, but it's pi y, so it's going to be pi dy dx. So we have plus pi cosine pi y dy dx equals 0. So what I would have to do here is I'd have to multiply out a bunch of things, get dy dx by itself. That, it's a bit of a hassle. So let's not do any of that. Let's do this the easy way. Well, I have this function, I have this equation defined here. So why don't I just take the 6th root of both sides? Why don't I just say cosine of pi x plus sine of pi y equals the 6th root of 68. Oh, so now when I take the derivative with respect to x on both sides, that's going to be 0. And looky here, we already found that derivative, right? It's literally just this thing. So it's negative pi sine pi x plus cosine, or pi cosine pi y dy dx equals 0. So let's move the sign over here. We end up with pi cosine pi y dy dx equals pi sine pi x. Then we divide by this term. We end up with dy dx equals pi sine pi x pi cosine pi y. But we don't need the pi on top and bottom because they cancel. So much easier if you work smarter, not harder. Because if you had done it this way, what you would have ended up with is a situation where you still would have had to solve this original equation, and you would have had to have said, oh, well, this thing is the 6th root of that, and so that's the 6th root to the 5th power, and it just would have been a whole thing, because you would have known that this is a constant, so you actually could have divided both sides by that constant, and it would have been okay because it's 0 on the other side, and it's a lot of work. Don't do that. Don't make your life any harder than you have to.